Okay, some people have already talked about some of the things I wanted to talk about, and one of the things is about programmability, that the scientific users that we are serving actually have very critical needs to discover scientific questions. And if a tool is not quite right for them, they won't use it, or they'll try and adapt it, or they'll try and write their own. So I think what I'm trying to get over here is, as academic software developers, we're a very, very small drop in a very big ocean of a much bigger software industry. To give you an example of that, in 10 years ago, when people were developing large-scale distributed computing, actually the majority of developers that were doing that were academic developers who were developing things called grids. Now, if you look at the development of distributed computing, it's completely different. The majority of people developing it are actually in commercial companies, and it's called cloud computing. Does that mean that all the effort we spent in latching those things together in those 10 years was a waste? I would suggest it wasn't, because what it did was it enabled scientific collaborations to start to work in a new way. And it gave them the appetite and desire for large-scale distributed computing, particularly for processing data, which is a different model from the supercomputing model that people have had before. And I think all of that work helped to do that. However, if somebody with the resources of Amazon comes along and presents something like a cloud, it's very, very difficult for us to compete with that, because they have so much more software engineering expertise, and they have such a larger user base. So what I'm trying to get at here is where should we as academic developers be looking to actually do our software development? And I think what we need to look at is things where scientists can't do something, maybe can't do it all on their own. The commercial tools are not ready yet. Their own programming skills are not quite sufficient for them to do it. I mean, this was very much the case, I think, with the grid stuff 10 years ago. And yet they need to be able to answer questions. So up here we've got one sort of thing that I've been considering for quite a long time, and that is an awful lot of work has gone into distributed computational infrastructures. At the same time, the environment is being instrumented with sensors which use completely different protocols and completely different programming methods, and this comes from the embedded computing community. And at the same time, actual users are using things like social networking tools to discuss and analyse all of this sort of stuff. Here are three worlds that basically don't talk to each other. Now, commercially, it's not at all clear that those things are going to be hooked up, because although there might be a very big need for people to develop social networking sites like Facebook and LinkedIn and all that sort of stuff, there's no reason for them to have links with sensors or instruments. Equally, people developing cloud computing may be doing things on a business model which doesn't actually include dynamic collaborations between people in the way that scientists collaborate, which is a very different model from the business model. So what I'm going to suggest is that I think that one of the things that we could usefully start to talk about during these 2 days is where are the needs for us as scientific software developers. Where are the tools that we need to give people so they can deal with these emerging architectures? They can have tools which they can actually program and adapt to their scientific needs, and yet things have not got to the stage where the commercial enterprises are going to come in and take over our work. To give you some practical example, I worked for 10 years on a project called Reality Grid, which was driven it was a bit like the Homer Simpson's car that Ian sort of said. It was driven right at the leading edge to use the most advanced computers in the world, all of which were non-standard. Okay, so we could not have built purpose-built vehicle with a general purpose vehicle. We had to build something that's very special. We did that on the grounds that the science could not have been done in any other way, and the science was sufficiently important to do that. And so when we talk about sustainability, we need to think quite a lot about these different levels. Sometimes we'll do bespoke things, sometimes we want things to go into a much more production environment. But we need to do it on a case-by-case basis.
Okay. Thank you.